Good afternoon, everyone. In this talk, you will learn how the Washington Post built a machine learning system for automatically moderating comments from millions of readers. We'll share the technical challenges with building the comment moderation platform and also how we raise the quality of online conversations with machine learning. I'm Patrick Cullen, Engineering Director over Data Science and Artificial Intelligence at the Washington Post. My team of data scientists and software engineers build personalization algorithms, ad targeting platforms, and products at the intersection of journalism and machine learning. I also want to introduce my co-presenter, Ling Jiang, Senior Data Scientist at the Washington Post. Ling is the creator of the comment moderation system that we'll be discussing today. Before we share the technical details, I want to share some background on why reader comments are important to the Washington Post. On the Washington Post website, we allow readers to post comments on news articles. These online conversations are critically important because it provides a way for our journalists to hear directly from their readers. In addition to feedback, comments build a sense of community as our readers share their views on important topics. Commenters are active and engaged readers, the type of readers we want to attract when building a loyal audience. Having this conversation on our website rather than just on social media platforms provides more opportunities for us to engage with our audience. Now, the challenge is that some comments are very bad and don't reflect the type of conversation that we want on our site. Trolls, bots, and incivility lower the quality of online conversations. Moderating comments is the logical step to enforcing our community guidelines and improving the quality of conversations on our site. However, with up to 2 million comments a month, relying on human moderation alone is cost prohibitive. We needed a way to combine the best elements of human moderation and machine learning to provide a high-quality solution that can scale to millions of comments. We call this system ModBot. ModBot is an online scoring system for reader comments. The ModBot API takes as input a reader comment and outputs a number between 0 and 1. Scores close to 0 indicate that the comment should be approved, and a score close to 1 indicates that the comment should be deleted from our site because it violates our community guidelines. ModBot includes a pre-filter, which uses a rule-based system to identify comments that use banned words. If the pre-filter passes, a machine learning model scores the comment and returns the score and moderation decision in the API call. All of this happens in real time so that each comment can be moderated before it is shown on the site. Let's walk through some example comments and see how ModBot scores them. Comment A would get a score close to 1 because of the highlighted words. A score close to 1 means ModBot would delete the comment. Comment B, on the other hand, would get a score close to 0 and be approved. Now, Ling will discuss how we built ModBot and how the model works in more detail.
Good afternoon, everyone. So I'm Ling Jiang. Next, I'll talk into more details. We built ModBot and how we will use it in production. We consider the problem as a classification task. So the classifier learns from the labeled training data with natural language processing and machine learning techniques. We collected over 60,000 comments with human labels, and we fed them into ModBot. So ModBot can learn from the data that deleted comments usually have lots of offensive words, many hyperlinks, lots of special symbols, while approved comments use lots of neutral or positive words, and they are usually pretty long comments. So after being trained, ModBot can differentiate bad comments from good ones. Then we can use this trained model to predict on new unseen comments. For example, on the right side here, we can see the comment in the red box calling people stupid will be deleted. And another comment in the green box sharing very good opinions on an article will be approved. So to train a system like ModBot, we need at least tens of thousands labeled comments. In our case, we already had this data because we had a human moderation system naturally. So next slide, please. For the classifier, we first used bag of words features to train the model. We represented each comment as a vector Each element is the word's weight in the comment. Then we run tenfold cross-validation with several different models. We can see the dataset is pretty imbalanced here with only 30% deleted comments. We compare the 5 different models here. The figure on the right here shows the receiver operating characteristic curve, which plots the true positive rate versus the false positive rate with different thresholds. So ideally, a perfect model's true positive rate will keep increasing with the false positive rate keep close to 0. So the closer the curve to the upper left corner and the area under the curve, the larger the area under the curve, the better the model is. So we can see here the logistic regression and SVM model performed better than the others. So we know it is important to compare different models to decide which one to use. And we need to make sure the metrics align with our business goals. For us here, we'd like to detect as many offensive comments as possible while keep the false positive rate low. And in addition to our bag of words feature, some other comments feature can also be used for prediction. For example, we observe that longer comments are more likely to include very meaningful discussion, and the comments with lots of links, special characters could be spam. So we extracted these additional features to retrain the model. As we can see in the figure here, additional feature did improve the performance. Here we are showing the performance of the SVM model. So the key point is we should always consider using domain expertise for feature engineering to improve the model performance. So one shortcoming of bag of words model is that they don't actually take into account the context of the comments. Hence, we also experimented with deep learning models, including convolutional neural networks, also known as CNN, and recurrent neural networks, which is RNN. So CNN considers the local context with the sliding window moving around, and the RNN makes use of sequential information to better capture the global context of the comments. In our experiment, we used the Google trained word to vacuum to initialize the word embedding, and we fine-tune them in the training process. We also put some limitation on the sequence length because we have observed some unreasonably long comments in the dataset. We also used the dropout layer for regularization. So we can see both CNN and RNN outperform the SVM model we have. And the CNN actually is a little bit better than the RNN. However, neural networks are much more expensive than SVM model, and the results are actually a little bit harder to interpret. So bag of words model are more explainable to humans, and that's why we decided to use the SVM model in production. So we don't always use the best performing model, and there are some other considerations like interpretability, as long as the difference in the performance is not too large. In order to understand the classifier's errors, we also ask the newsroom staff to manually look at the comments that ModBot labeled differently from humans. So here is a user interface for the staff to review if there is a conflict. They can decide which label is right and specify the reason for the decision. We listed a few reasons here for them to choose, and also they can input their own reason. For example, the human moderator approved this comment here, but ModBot actually suggested deleting it. After reviewing this comment, the newsroom staff agreed with ModBot, since obviously it's a very personal attacking comment. We also found that human moderators, they are more likely to over-delete comments that were flagged by other readers. So we know here, human moderators also make mistakes. And we need to account for this mislabeled data in our training process. And this human review process also helps us capture the reasons why ModBot is wrong about certain predictions. And we can refine the classifiers accordingly. For example, In this comment, ModBot suggested deleting this one due to the word idiot. However, human moderator approved this comment because the post allows criticism of public officials, which includes celebrities, organizations, and journalists. And we found this to be a very common reason for some wrong predictions. To handle this issue, we added a named entity filtering layer to pre-process the comments. If we find a public official as the subject in the comment, we remove the suspicious word before scoring the comment. In this example, we remove the word idiot following the public official named entity here before passing it to ModBot, and we can finally got it approved. To handle this mislabeled data issue, we have this human review process in the training loop. After ModBot predicts on comments, human reviewer can modify the labels if they find the conflicts using the interface in the previous slide. And then the revised data can be fed back into the training process to retrain the model for better accuracy. And we can update the model iteratively by keeping humans in the loop during the training process. In our production, we can use threshold for automatic moderation with ModBot. For example, if we use 0.8 and 0.2 here, anything above 0.8 will be deleted automatically, and all comments below 0.2 will be automatically approved, and everything left between are not given a moderation score yet. And this comment will be posted to the site and policed by the readers flagging. Human reviewers, they can step in if a comment is flagged by a reader later. So we keep humans in the loop during the inference step as well, and we allow them some flexibility in deciding the threshold. In this example here, we can see ModBot is pretty accurate, but there is still a big chunk of the comments in the middle section might require manual process. So we can shrink the middle section by adjusting the threshold here. For example, we can decrease 0.8 to 0.6 to automatically delete more comments, and increase 0.2 to 0.4 to automatically approve more comments. And also please note that the number of comments is not distributed linearly along the threshold. Increasing 0.1 on the approval end will include much more comments than decreasing 0.1 on the deletion end. And this is because of the imbalanced nature of the dataset. So by adjusting thresholds like this, we can automatically moderate more comments, but we will see we can also include more errors. So there is a trade-off between automatic moderation and accuracy here. And we can work with the stakeholders to understand this trade-off to set the threshold in production. So that is all about ModBot. Thank you for your attention. Next, we'll take your questions.
So Ling, I'm looking at the questions here. This one is, do you have data on how many readers interact with comments? Do you want to take that one, or you want me to?
Yeah, if you know, you can
Sure.
go ahead.
So we do have data on that. And one thing that we're working on now, we didn't really talk about the future of ModBot, but we're trying to understand different readers' behaviors over time to kind of build a reputation score to help us better moderate. So that's one of the things that we're looking at, is the interaction between comments. Right now, ModBot works off just a comment, so it doesn't look at the history of a reader and their interaction with comments. And the next question, what data set are you using to train your model? Do you want to answer that one, Ling?
Sure. So the data set we are using is a data set that was human manually labeled by our moderation team. So usually we send some flagging comments and the comments from new user to them, and they will manually look through them and then manually label them.
Yeah, so we actually have a team of human moderators, a very small team that does this. And so ModBot was built to supplement that team, but that team had already built up a significant data set of hand-labeled comments. whether they matched our terms of service. So that's how we got the initial data set. And Ling, do you want to talk about what was the size of the data set?
Yeah, the size for the training set was 60,000 comments.
Excellent. And what time frame did that cover? Was it a year, a couple of years?
Yeah, if I remember right, it should be a month because
Couple of months, okay.
in the old days we don't manually label all the comments, so that's why the size is a little bit small compared to the total number of comments we have on our site.
Right. The next question is, how do you apply your domain knowledge to your model, and how does that scale? So I think Ling hinted at this, but one of the things that we learned is to incorporate the domain experts in the training process. So if you remember the slide that Ling showed where there was a user interface that allowed you to basically to correct the automatic moderation decisions, we used that during the training process to get domain expertise from the people who were actually doing the moderation. And that's what led to the insight that helped us adjust the architecture where we needed to identify comments that had entities in them that were allowed to be criticized according to our terms of use, or our community guidelines on our site, whereas an attacking comment against just a regular user was considered not approved. So that was, I think, one way that we were able to scale that domain expertise is to build that user interface and collect that feedback. The next question is, Facebook and Twitter have had a hard time moderating content. How does your solution improve on what the social media giants are having difficult solving with their enormous resources? I think when it comes to comment moderation, each company has different goals in mind. I think for Facebook and Twitter, they probably have different goals. I mean, they're very advertising driven. And so I'm sure their moderation decisions are based partly by business decisions. The same is true on our site. I mean, our goals for comment moderation is actually to build a loyal audience of readers that want to become subscribers. And so we have different goals. So I think it's important to identify what your business goals are and adjust the model and the performance of the model to achieve those goals. So I think, although I'm sure there are similarities in the approach that we're using and what they're using, I think it's very important to understand the business context of what you're trying to do and make sure your model implements that. Next question is, what was the biggest struggle you had when trying to find the optimal solution? What do you think, Ling?
I guess the biggest struggle would be the data issue we mentioned here. Like humans make mistakes, so that's why we have some mislabeled in the data. So if we feed those mislabeled data into the model, we cannot get a very optimal model. So that's why we keep human in the loop to help us to improve the model iteratively.
Excellent. The next question is, how have you implemented ongoing monitoring to track model performance?
Yeah, we have Datadogs metrics to track all the time. We track how many comments we automatically approve or delete, and we also send our ModBot moderated comments into the moderation team, so they can so those conflicts can be surfaced to them, and they can keep an eye on that.
We also get some direct feedback from our comment moderation team when they find comments that they think should have been obviously automatically moderated, and that's helped us to tune the model as well. The next question, how do you define success for your stakeholders? Would you be able to share a little bit of the model serving architecture? Sure, two different questions. How do you define success for your stakeholders? So I think this is a really important element that you have to keep in mind when building machine learning systems that are practical, is you have to understand your stakeholders and what they want to achieve. In our case, our stakeholders really wanted to supplement the human moderation team. They didn't want to necessarily replace human moderation, but they wanted to help that team scale. And so they were looking for that type of solution where it would handle, as Ling was showing those thresholds, it would handle the outliers that were either obviously good comments or obviously bad comments to really help them scale. And so that's how we defined the system and built it. I'm sure in other companies it might be, maybe 100% automation is the key goal from the stakeholders. But in our case, that's what we found when talking to the stakeholders. And then would you be able to share a little bit of the model serving architecture? Ling, do you want to explain how the model gets served production?
Yeah. Yeah, so basically when a comment was posted to the site, we have a talk system that will pass the comment into the ModBot. We'll call the ModBot API, then we will return the score. And we use this threshold to add the tagging to the comment, either like a delete or approve or no decision, and then we pass that to the talk system again.
Yep, excellent. And we use Python actually for the serving architecture. And it's actually been surprisingly effective. I mean, SVMs perform really well, I think in production scale very well. See the next comment, the next question. Because of the nature of the problem, possibly rejecting comments are the minority, but your final score is well balanced between 0 and 1. What is the process of getting a balanced scoring output at the end?
Let me understand the question.
I think this is trying to set, since the data is imbalanced, how do you make sure that the scores represent an even distribution, an even representation of the distribution with an imbalanced data set?
We are not trying to make the score evenly distributed. As I mentioned in the threshold slide, actually the number of comments on the approval end is much larger than the number on the deletion end. Even comments below 0 millions, but on the other end it could be like thousands. So that's why we use this threshold techniques to manage how we want to automatically moderate the comments. So on the approval side, we can decide much lower score, but on the deletion side, we can use like higher score.
Right. So the score represents a kind of a probability, but you can adjust the upper and lower bound independently. And so I think when we were adjusting those, we actually worked with the stakeholders to understand where they want to set both the upper and the lower bound for both automatic deletion, automatic approval, based on where they thought, the human moderation could improve upon what ModBot did versus, ModBot doing a better job. The next question is, was there an imbalanced learning issue you came across at some point? And if so, how did you tackle it?
Yeah, we sure do, because the data set we have is very imbalanced. So we used a few techniques, like we tried subsampling, which didn't work pretty well. So we finally used the cost-sensitive function in the model, which worked pretty well with our model.
Can you explain a little bit more what the cost-sensitive function is?
So basically, yeah, we penalized, we added more punishment to the wrong prediction for the deletion versus the wrong prediction on the approval, because the deletion number in the dataset is much less. So that's why we put more punishment on that end.
Got it. And so that would improve the accuracy of the deletion.
Yes, right.
Excellent. Great. Any other questions? Oh, is this open source or maybe an available public API? It is not open source or a public API, although we have talked about making it a service that we would offer to other companies. But at this point, it's not. There is some cost associated with running it as well, since it is executing a model on each request. And the next one is, are there any plans in incorporating bot detection into the review process? Yes, we actually are working on that now. So one of the things I alluded to is that we're building a reputation score, which we think will help us kind of get to the next level of accuracy, which looks at not just the words in the comment, but the history of a particular user and their comments, including have their comments been flagged by other readers, how recently did that person sign up for an account, some of these things to kind of build a reputation to help detect bots. Because if you've ever tried to run these kind of like user-generated content, the people running the bots are very sophisticated. So we have to keep working to stay ahead. Good question. Great. Any other questions? Great. Well, I think, one more question. What are some other data projects at the Washington Post? That's a great question. We do a number of different things. One thing that we have built that's pretty interesting is a topic classification system. And what it does is it automatically learns which topics each article is about. And we use that to help personalize recommendations to our readers. And we've had really good success with recommending, different types of articles that match people's long-term reading interest. And so we've built several different products. You can kind of think of them like a very lightweight version of like the For You recommendations that you get on like Google News or Instagram or something. It's not as sophisticated, but it's been some really interesting things. So we also work on that as well. So there's a question, is the topic model a supervised one? It is. It's actually using supervised learning, which is is problematic. Unlike with ModBot, we didn't have a natural source for the training process for the topic model and had to use some various techniques to generate a training source, which is challenging. And then another question, do you have a machine learning model in place for separating real news from hoaxes? We don't. We've actually talked about detecting something a little different, but trying to detect fake images and fake videos and other things like that. I think that's still kind of in the experimental phase, but that's also something that we've been interested in as well. Great questions. All right. Well, if there's no more questions, we'll let you guys get a couple of minutes back. Thanks so much for attending our session.